Welcome to the session. Today we are going to discuss about one force analysis. Force analysis means when your body is moving under the condition, what are the forces acting on the body? Those things we have to analyze. Those things we have to discuss in this first unit. It is called as force analysis. This force analysis can be classified into two categories. First one is the static force analysis. Next one is the dynamic force analysis. What does mean by static force analysis means? When the inertia effect due to the mass of the machine particles are neglected in the analysis of the mechanism. That means we are not considering the inertia force, the body is under the rest condition. Body is under the rest condition, then only the inertia force is neglected. That condition we have to study in which is called as static force analysis. The dynamic force analysis means when the body is moving, there will be then some inertia will act. When the inertia forces are considered in this analysis of the mechanism means that is called as dynamic force analysis. Next, what is inertia? It is an imaginary force. Inertia force is an imaginary force. The force is equal in magnitude but opposite in direction and collinear with the impressed force producing the acceleration. For example, a body is there over the body there is a force acting. What happens due to that force? The body tends to move. So the body starts to move due to the weight of the body, and also it's try to move. What will happen? The opposite direction, a resistant force will be start. That force will be equal and opposite direction of the force applied on the body. Okay, that will be equal to that force. That imaginary force is called inertia force. For example, normally the force is applied on the body F equal to ma, mass into acceleration. So this inertia force will be equal and opposite direction. That's why we apply the same ma, but the sign minus indicates the opposite direction. The next inertia torque. It is also the imaginary torque, which when applied upon the rigid body, bring it in equilibrium condition. It is equal to the acceleration coupled in magnitude but opposite in the direction. Similar as the body is in rest, when the force acting eccentric to its axis, what will happen? The body tend to rotate, try to turn or rotate. So that rotating motion is resisted by the weight of the body, some external force. That force is called the inertia force. So the coupled movement is again bring to equilibrium. How it's happened? By the resistant force. That resistant force is called as inertia torque. That opposite coupled movement is called as the inertia torque. Normally we have to know inertia torque. Normally the torque equal to I alpha, not angle of movement. I alpha. So inertia torque will be same, but in opposite direction. That's why we are using the negative sign I alpha. Next, D'Alembert principle. The D'Alembert principle said that the resultant force acting on your body together with a reverse direction effective force or inertia force or in equilibrium. For example, some of the external forces are acting on the body. Some external torques are acting on the body. So, what are the forces, what are the torques acting on the body? We have to sum it. So, we have to sum all the external forces and inertia. Okay, all the moments and inertia torques. So it's become zero. That's when the D'Alembert principle says. So now we come to the dynamic analysis in a engine. The velocity and acceleration of the reciprocating parts of the steam engine or internal combustion engine may be determined by graphical method or analytical method. So dynamic analysis means we already know that dynamic means what are the forces acting on that, what are the velocity, what's the acceleration. So all those things we have to study. So that is dynamic. So dynamic consists of reciprocating part means reciprocating engine. In the reciprocating part, what are the forces acting on that? What's the velocity? What's the acceleration? So those things we have to study. So we have studied by using graphical method or analytical method. The graphical methods are classified into three categories: Finn's construction, Redon's construction, and Bennett construction. So three types of graphical construction methods are there. Actually, we have the analytical method. First, we are going to discuss about the analytical method of reciprocating part dynamic analysis. Consider a crank and slaughter in reciprocating engine as shown in figure. Initial position of the crank is of the original position. For example, C dash to O is the initial position. At the time, the connecting rod CP will be in the position of C dash P dash. The radius of the crank is R. The length of the connecting rod CP is L. Initially, the crank is in the original position. The C dash is the AIDC in the dead center. The C double dash is the outer dead center. So length of the connecting rod PC is indicated by L length. So at the original position, it will be positioned at the P dash C dash. What will happen? The crank rotates theta degree from the horizontal. So it's the C dash move into C. So the reciprocating movement will be taken as P dash to P. So it's move the distance in the original direction x. So the length of the crank L, radius of the crank R, theta is the indication of crank to the line of stroke, then in the horizontal direction. N is the ratio of the length of the connecting rod to the radius of the crank. L by R ratio is called as N. So we need to find out the displacement initially. So X is the displacement take place of the reciprocating part. X. So P dash to P. The P dash to P is again we have to subdivide into OP dash minus OP. From the OP dash we have to subtract the OP, we get the P dash to P. The OP dash can be classified again subdivided into P dash C dash plus C dash O. Then OP is we can rewrite as PQ plus QO. So the P dash C dash is equal to L. C dash O is equal to R. So L plus R. The PQ can be rewritten as L cos phi because of the angle of the cantilever rod with respect to horizontal is phi. So PQ is equal to L cos phi and QO is equal to R cos theta. So we have to substitute this value in this equation. We get R into 1 minus cos theta plus L into 1 minus cos phi. So we have to take R from this equation. So R into 1 minus cos theta plus 1 L by R into 1 minus cos phi. Then the formula can be rewritten as R into 1 minus cos theta plus L by R is equal to N, we know that. So N into 1 minus cos phi. But in this equation, R we know that, theta we can know that, N we can easily know that, but pi value we not able to identify easily. That way we have to change the pi value into in the terms of theta. So that's why we have to CQ equal to L sin phi. The same value equal to bigger or sin theta in the right angle triangle of the two triangles. So L by R equal to sin theta by sin phi. So N equal to, so L by R equal to N we know very well. So N equal to sin theta by sin phi. So sin phi is rewrite as equal to sine theta divided by n. We have to substitute that value. So cos pi is equal to 1 minus sine square phi power 1 by 2. So sine square phi is equal to sine theta divided by n. We know that. So 1 minus sine square theta divided by n square power 1 by 2. So expansion for that is equal to in the form of cos pi is equal to 1 minus 1 by 2 sine square theta divided by n square plus like that. So the higher values are negligible amount. So this equation can be rewritten as 1 minus cos pi is equal to sine square theta divided by 2 n square. So we substitute that value, we can find the x is equal to r into 1 minus cos theta plus sine square theta divided by 2 n. So we know that velocity is change of displacement with respect to time taken. So we have to differentiate the x with respect to time. But here the changing variable is theta. So that way we have to multiply the and divide by d theta. Okay, so the equation becomes dx by d theta into d theta divided by dt. So d theta by dt we know that omega. So that becomes dx by d theta into omega. So dx by d theta is equal to, again we have to differentiate the x with respect to theta. So r into sin theta plus sin 2 theta divided by 2n. So we substitute this value in this equation. So we get velocity of the piston Evo. Vp is equal to, so omega r into sin theta plus sin 2 theta divided by 2n. Similarly, again with respect, we have to differentiate the velocity with respect to acceleration. Differentiate the velocity with respect to time, we get the acceleration. So dvp divided by dt. So the variable is d theta. So that's why we have introduced multiply by d theta and divide by d theta. It's become dv by d theta into d theta by dt. So d theta by dt is omega. So again differentiate the velocity with respect to d theta. We get omega r into cos theta plus cos 2 theta divided by n. We substitute this value in the above equation. We get the acceleration of the piston is equal to omega square r into cos theta plus cos 2 theta divided by n. So when the crank at the inner dead center means theta equal to 0, at this position we have to substitute the theta value 0. What will happen? The acceleration of the piston become omega square or 1 plus 1 by n. Similarly, at the extreme position 180 degree, cos theta is equal to cos 180, we have to substitute. So what will happen? The acceleration become omega square r minus 1 plus 1 by n, the value. As the direction of motion reverse at the outer dead center, therefore change of the sign of the above expression. You know that. Okay.